Okay, morning. Okay, so this homework here, I just had a look in your folders and I think 3 people have the graph done. Granted, it's still early, but yeah, there's no point in me going through it if you guys don't have it done. Okay, so will you make sure you have this graph done, photographed, and put into your OneNote folder? Just going to Antonio's here. So in your homework folder, into this one, a photograph should be in there. Okay, so get that done, and then I will go through the solution to that. Okay, now the next thing we're going to do, or the next thing we would be doing, is the experiment here. Ugh, that's not a straight line. Okay, so this is the experiment where we use the linear error track again, but this time for acceleration. Okay, so the setup is here, the picture just above. So it's exactly the same as it is for velocity, except that instead of us wanting these gates to read the same thing, because the trolley is moving at a constant velocity, that's not what we want anymore. So we want it to speed up. When it's here, it should be going slower. Yeah, so it should take a longer time to go through the first gate. And then by the time it gets to the second gate, it should be going faster. So the time to the second gate should be much quicker. Okay? The way we accelerate it is by using weights. Okay, if you follow, there's a string, follow the string back up. The string is tied on here to the trolley. So you put weights in, the weights are just hanging in midair. You drop the weight pulls the trolley through and it accelerates. So that's how we get it to accelerate. Rather than just throwing it down the track, you want something a little bit more kind of structured. So this is how we do it, all right? I'm not going to go into it now, but this is, like, technically speaking, we use this experiment just to, like, it's not really about the force, it's more about just calculating the acceleration. But literally the next experiment we do is about the relationship between the force and the acceleration. So you kind of do the same experiment twice. So if we don't actually do this one, technically we'll be doing it in the next experiment anyway. Okay? So I need you to write it up, obviously, because it's one of the mandatory experiments. So what I want you to do is go in here. Here is the second one. So mechanics 1 part 2. And you can start writing it up, okay? Read it, don't just write it, okay? So I was going to take all this writing off, and then I decided not to because it's how we do the experiment. So just very briefly, up here, this is the definition for acceleration, v minus u over t. And I have shown you, they're here. I've shown you, and we've used 3 equations of motion down here. You've done the derivations for them. So these are your equations of motion. So it just, I suppose, which one you use depends on the equipment you're using. Okay? We use the one here circled in yellow. Okay? Because that's how our equipment works. All right, so I don't know why I've done it twice, but anyway, I've rearranged it twice, obviously 2 different years. Rearranged to calculate acceleration. Yeah? So v squared equals u squared plus 2as, I minus the u squared, and then I divide it by 2s, and you end up with this in the red box. And that's the formula that we use to calculate acceleration. Okay, so I go through on the diagram how to calculate u, how to calculate v, and then ultimately how to calculate s. Yeah, that's down here in purple. Okay, so I have it here, how you calculate V, how you calculate U, how you calculate S. So have a look through that, make sure you understand it. It's a bit more complicated than the last one. Have a read of the method, although it's going to be quite similar to the last one. But have a read of that, make sure you know how to do it. This is your table, so you can put the table into your write-up and just leave it blank, and we'll fill it in then whenever we do the experiment. Show one calculation, so again you won't be able to do that. The conclusion, you'll be able to write the first line. In this experiment, I aim to calculate the acceleration, then you'll have to stop. And then the errors, again, are the same as they were for the last one, so you can write them. Okay, so, I mean, this doesn't need to be written up today, but it needs to be written up. And then this is a question that I would like you to do. So this is based on the first experiment, Mechanics 1, Part 1. And this is based on that experiment we just talked about there, Mechanics 1, Part 2. Okay, so just to be clear, what I want you to do is, if you haven't done the graph already, do the graph, photograph it, and put it into your homework folder. I then want you to go in here, have a read of this experiment, make sure you understand what you're going to do, how you're going to use the equipment to calculate acceleration. I then want you to do this question, photograph it, put it into your homework section, and then when that's finished, you can start writing this up. Okay? So today's Wednesday and we don't have, so this is literally for next Wednesday. So by next Wednesday, I should be able to see these two pieces of work in your folders, in your homework folders. And when I come back, then that experiment should be ready to go. All right, hope that is clear.